Okay, so this is for homework 2. The first problem is 2-24, and then first you do a balance of in minus out plus generation is equal to the change in energy over time. Since it's steady state, the right side of the equation is 0. And then you just go through, use Fourier's law to change it a little bit, and then take the limit from delta R approaching to 0, which is the thickness of the container. And at the end, you get that differential equation for the change in temperature over the radius of the container. For this question, you're given a lot of values. You first set up, you're given that temperature equation, and then you have to prove it. So first, it's steady state, double differential is equal to 0. Integrate twice, use your boundary assumptions to find the unknowns C1 and constant C1 and C2, and then eventually plug it all in, you get 224 watts per meter squared. For the third written out problem, you're given a few values here, and then again you start with the boundary conditions, so steady state, and then also this one right here, I'm still a little confused on all the boundary conditions. I'll come back to that in terms of my points of confusion. But then you're going to integrate again, solve for C2, and then plug it in, and then solve for when R is equal to 0, which is the middle of the fluid. And you get a temperature of 125 Celsius. The final written out problem is just mass balance stuff. You're using Henry's law, and so you know the Y value of water. So the amount of water in liquid form is just going to be the pressure over the total pressure, partial pressure over the total pressure. So that's a small number, 0.018. And then you find the partial pressure of the air by subtracting total minus partial of water. And then in the table 14.6, I believe, you find the H value, 5900 bar, and find the amount of air in the water by dividing the partial pressure of the air by Henry's constant. And so, for some points of confusion, I'm still pretty confused on the boundary conditions. They're a lot more complicated, and there's obviously twice as many of them as compared to the fluid's boundary conditions. So I think I just need more practice with applying those and seeing examples with those in them. But other than that, all the mass balance stuff seems pretty straightforward. So yeah.